Hello and welcome to Physics Teacher. Well, Chemistry Teacher today, because I'm going to be going over a titration lab that I do with my grade 12 chemistry students. Now, if you've never done a titration before, you can go check out the titration I do with my grade 11s, which is a strong acid with a strong base. But with my grade 12s, we're going to be doing two of them. The first one is going to be a strong base with a weak acid. So we have sodium hydroxide and we have acetic acid. And then we are going to be doing a weak base, so we have ammonia, with a strong acid. We have hydrochloric acid. We're going to be titrating them both. Now the goal is to determine the concentrations, pH, and percent ionizations of our weak acid and bases. Now, if you want to see the calculations for how you do that, I made a separate video, and I'll put a link to it in the description for how we do those calculations. But in this video, we are going to perform the measurements that we need in order to do those calculations. So to start, let's start with our weak acid. So my weak acid is acetic acid, and I'm going to be putting exactly 20 milliliters, 20.0 milliliters of acetic acid into this flask. And I'm going to prepare, I have some sodium hydroxide. This is our known concentration of 0.5 moles per liter. So 0.5 molar sodium hydroxide. That's our strong base. I'm going to put this into our burette. I don't need to fill it all the way because I don't think I'm going to need that much. So we have it at an initial value of 16. Wow, 16. That's a good start. So we're starting with our weak acid. Our initial value is 16.0 milliliters. So we're going to titrate that into exactly 20 milliliters of acetic acid. And I'm going to use my pipette to get exactly that amount. Now this pipette is a 10 milliliter pipette, so I'm going to need to do this twice. So here's 10 milliliters. And we'll get another 10 milliliters. Right, now a good indicator to use when you have a weak acid and a strong base is phenolphthalein. So I'm going to put 2 drops and 1 for good luck. Into my acetic acid. So I need to titrate this until it just turns to a nice baby pink color. Now if you've done a titration before, you know this is going to take a while. So from this point, I will speed up the video for you. Let's get started. Did I get it? Is that gone a pinkish? Let's try one more drop. There we go. There's our baby pink. And it's nice and sustained. So we are at a final volume of 35.6. So our final volume, 35.6 milliliters. So that's all we need to know to be able to do our calculations. Let's move on to our weak base. So same thing, here we have ammonia. That's going to be our weak base. And I'm going to put exactly 20 milliliters of ammonia into our flask. Our strong acid is going to be hydrochloric acid, and it is 0.5 moles per liter hydrochloric acid. Okay, and I'm going to fill this up to a certain amount, and we'll check our initial value. So I think that's good enough, and our initial value is 7.7. So our initial value, 7.7 milliliter marking. All right, let's take 20 milliliters of ammonia. All right, so we got our 20.0 milliliters of ammonia at an unknown concentration. And when we're dealing with a weak base and a strong acid, methyl orange is a good indicator to use. So I'm going to put in 2 drops and 1 for good luck. You can see the color is a nice yellowish color. We need to get that to change to just change to an orangish color. Let's start our titration. There we are. There's our orange color. All right. Let's see what we're at. Oh, exactly 18. All right, so I hope you enjoyed those labs. If you want to see how to do the calculations, you can check the link in the description. If you want to copy those calculations and test to see what the concentrations of our weak acid and bases here were, let me know what they are in the comments. And if you like the video, leave a like, and don't forget to subscribe. Thank you.